Hi, I'm Dan Gelbart, and that's a short course on how to build stuff. And the course is mainly for students and scientists, researchers who are not machinists by training, which means the emphasis in this course is how to build things very quickly using equipment which is very easy to master. So altogether, it's applicable not only to prototypes, it's also applicable to some limited production. But the biggest benefit is for prototyping. And the enabling technology which makes life so simple is water jet cutting, which we'll see in a few minutes. So altogether, what we'll cover first is a basic setup. In other words, the tools and the machines you need. We'll cover the modifications which is desired to put into those machines to make them even more productive. And then we'll go step by step and fabricate some parts, starting with a simple enclosure. So before we get into fabricating a part, I just want to show you the wide range of things you can take advantage of water jet cutting. So obviously the thing which is most common is enclosures, starting from very simple boxes like that. If it's for R&D work, you try to make it with all captive hardware. In other words, notice there are no screws holding the cover, just snaps in place. There is knockouts cut in just like on electrical boxes to avoid later on drilling. Wherever possible, it uses keyholes instead of regular holes. And this is a huge time saver, not only because you don't have to take the screws out to remove it, but also you avoid the common problem of a screw which is taken out falling into some part of the machine where it shouldn't, typically falling into something electrical and shorting the works out. So that's, with a water jet, it comes at no cost. The other thing you can do in enclosures or parts with a water jet, if they have to be very lightweight and strong, you can emboss them. So basically what you do, these ribs were put in 1 minute with a die made on the water jet. Basically, the die is made of 2 pieces, spot welded together. This is cut on the water jet, and then you can put in the ribs, make it lighter. Something you'll notice in all these boxes, that I tend to design the boxes that it's made of U-shaped pieces instead of bending a piece on 4 sides. So in other words, this box is made of a big U and 2 little U's which are spot welded in. Now the reason why the preference is to make everything of U-shaped pieces instead of like a flower with four pieces is U-shaped pieces can be bent on the brake without having to move over the segments. If this was bent from 1 piece, I would have to adjust the segments to fit in, and that takes an extra couple of minutes to find the right combination of brake fingers or brake segments to fit in. But if this is a U, I bend it with a full-length bar, I don't have to touch the brake, I don't have to modify it. So both this piece and most of the boxes, the best thing is design them from a combination of U's. In general, of course, you can't bend on a brake something which is too deep because it will interfere with the brake. Now, another thing which is a natural for water jet cutter is flexures. So flexures can be either monolithic, and we're going to talk in details later about them. It could be very tiny, and I'll just hold it here so you can see it. These are as small a flexure as you can actually make on a water jet. These were for fiber optics, and this little one, as small as it is actually a 4-axis positioner. It has X and Y flexure movement, and it has theta and phi tilt at the back with 2 more set screws. Now you can also make flexures just from spring material like this, where everything is sheet metal. The middle part moves, and these are spot welded springs which are spot welded in. Okay, in this case the springs, and some of the flexure, in this case for sure, the springs are nitinol instead of steel in order to get a very large elastic range. This is what's called a cross spring hinge. It acts like a normal hinge, but it's all spot welded with nitinol flexures. Of course, the advantage of these flexures over slides is that A, there is no wear, B, there is no lubrication, C, there is no backlash. And D, you can make it in a few minutes instead of paying hundreds of bucks for a slide. So this is a natural thing for a spot welder. Now, another thing which works well with a water jet is very large structures, where this is just a sample, and we'll talk more about large structures. This is a 1/10 model, which we'll discuss later. And you can make quite complex assemblies made from those elements, and let me show you a couple. Okay, so here is a few more examples of what you can fabricate using the methods shown in this course. A very simple thing you can fabricate on a water jet is springs, all the way from springs carved from solid steel, which can be cut from the hard material or cut in the annealed state and hardened. And these are springs which need a few hundred kilo to compress. If you wanted to wind them from wire, it would be a wire the diameter of a pencil, which would make it very hard to wind. Now you can go and make very nice disc springs like this with a spiral. And the two nice things about these disc springs is first they go completely flat. When you compress it, it compresses to the thickness of the material. So they go completely flat, which means minimum clearance. The second nice thing about those springs is that they don't have to be constant K springs. Matter of fact, if I cut a spiral with a constant width, the spring will not be constant K, because the outer spiral will deflect more easier than the inner spiral. So actually it would be a progressive K. If I wanted to make this constant K, I would linearly taper down the spiral. But that means that I can take any plot of force versus distance I want, convert it to a spring design, and I can make an arbitrary K function for the spring, which is quite convenient because sometimes you want springs which have a very wide dynamic range. They are affected by a little bit of pressure, but then they can hold, before bottoming out, a big pressure. So the ability to make a spring where the K is continuously programmable as a function of distance at the same cost as a regular spring is very nice. Other things you do on a water jet is you minimize machining. If you need parts which have to be very accurate beyond the accuracy of the water jet, obviously you will water jet the whole part and touch it up on a machine. But the way to do it is you water jet it, paint it, and then clamp it, and after painting touch up the surfaces. This is much faster than the normal way of masking the precision surfaces and then painting, and always cleaning the leftover paint. Because this way the paint is tough enough to clamp in a vise and do the machining. Another example where 95% is done on the water jet and 5%, just the rim, is machined afterwards. Now, some stuff looks complicated, but actually it's a combination of very simple structures. Like this is some gearbox which rotates in two directions on two axes, but actually it's just made like simple enclosures, and the bearings are little bearing mounts, are just little inserts permanently attached, in this case with screws, to the housing, just to give more support to the bearings. So this looks like a complicated assembly, but actually it's built like enclosures. The gearing itself is done with timing belts inside. There's also some slip rings. And again, note that everything is done with captive hardware and keyholes, so you don't have to remove any screws to open it. So it shows you that even complex parts can be broken down into a few simple assemblies, all of them made from spot welded bent metal. And wherever you need a thicker section, you can add it on or weld it on and machine it after the whole thing is finished. Now here is another example. This is some type of a chuck, which you turn this, it grips at different diameters. Now this looks like a completely machined item, but surprisingly there is nothing machined in this whole thing, because everything is made from water jet parts. This is a pipe and a ring pressed together, and even the scroll inside, which activates the arms, the scroll inside is a water jet cut helix in which a flexible steel strip is inserted. And the advantage of this is that the spring is already hard and smooth, and if you had to do it from one piece, this piece would have to be steel, and then you would have to grind it on a CNC grinder in order to get good accuracy and wear. And that's quite a lot of work to make it from steel, harden it, grind it on a CNC grinder, and compared to just inserting a steel ribbon in a water jet cut helix.